Section 6.4, Deployment Pipeline, Package and Publish. In Chapter 3, we started implementing a deployment pipeline to support continuous delivery for the Polar Bookshop project. Continuous delivery is a holistic engineering approach for quickly, reliably, and safely delivering high-quality software. The deployment pipeline is the primary pattern for automating the entire journey from code commit to releasable software. We identified 3 main stages for the deployment pipeline: commit stage, acceptance stage, and production stage. We'll continue focusing on the commit stage. After a developer commits new code to the mainline, this stage goes through build, unit tests, integration tests, static code analysis, and packaging. At the end of this stage, an executable application artifact is published to an artifact repository. That is a release candidate. Chapter 3 covered all the main steps except for the final packaging and publishing of a release candidate. That's what you'll see in this section. Section 6.4.1, Building Release Candidates in the Commit Stage. After running static code analysis, compilation, unit tests, and integration tests, it's time to package the application as an executable artifact and publish it. In our case, the executable artifact is a container image that we'll publish to a container registry. An essential idea in continuous delivery, also present in the 15-factor methodology, is that you should build artifacts only once. At the end of the commit stage, we'll produce a container image that we can reuse in any following stage in the deployment pipeline up to production. If the pipeline proves something is wrong, a test fails. At any point, the release candidate is rejected. If the release candidate goes through all subsequent stages successfully, it's proven to be ready for deployment in production. After we build an executable artifact, we can perform additional operations before publishing it. For example, we could scan it for vulnerabilities. That's what we're going to do with Gripe, much as we did for the codebase. A container image includes application libraries, but also system libraries that were not included in the previous security analysis. That's why we need to scan both the codebase and the artifact for vulnerabilities. Figure 6.15 illustrates the new steps we will add to the commit stage for building and publishing a release candidate.
Figure 6.15. At the end of the commit stage, a release candidate is published to an artifact repository. In this case, a container image is published to a container registry.
Once a release candidate is published, several parties can download it and use it, including the next stages in the deployment pipeline. How can we ensure that all interested parties use a legitimate container image from the Polar Bookshop project and not one that has been compromised? We can achieve that by signing the image. After the publishing step, we could add a new step for signing the release candidate. For example, we could use SigStore, www.sigstore.dev, a nonprofit service that provides open-source tools for signing, verifying, and protecting software integrity. If you're interested in this subject, I recommend visiting the project's website. In the following section, I'll show you how to implement the new steps in the commit stage of our deployment pipeline. Section 6.4.2, Publishing Container Images with GitHub Actions. GitHub Actions is an engine that you can use to automate software workflows directly from your GitHub repositories. Workflow definitions are conventionally stored in a GitHub Workflows directory placed in the root of a repository on GitHub. In Chapter 3, we started developing a workflow to implement the commit stage of the deployment pipeline for Catalog Service. Let's now continue the implementation by adding further steps to package and publish the application. From your Catalog Service project, Catalog Service, open the workflow definition for the commit stage, github/workflows/commitStage.yml, and define a few environment variables to store some essential facts you'll need when building a container image for the application. By using environment variables, you can easily change which container registry you use, or the version for the release artifact. Remember to add your GitHub username, all in lowercase, instead of the placeholder in the following listing. Chapter 15 will cover software release strategies, but until then, we're going to tag every image with latest instead of a version number.
Listing 6.9. Configuring facts about the release candidate.
Next, let's add a new package and publish job to the workflow. If the build and test job completes successfully and the workflow runs on the main branch, the new job will be executed. We'll use the same strategy we used locally to package Catalog Service as a container image, relying on the BuildPacks integration provided by the Spring Boot Gradle plugin. Notice that we are not pushing the image directly. That's because we first want to scan the image for vulnerabilities, which we'll do in a moment. For now, update the commitstage.yml file as follows.
Listing 6.10. Packaging the application as an OCI image using BuildPacks.
After packaging the application as a container image, let's update the commitstage.yml file to use Gripe to scan the image for vulnerabilities and publish a report to GitHub, similar to what we did in Chapter 3. Finally, we can authenticate with the container registry and push the image representing our release candidate.
Listing 6.11. Scanning the image for vulnerabilities and publishing it.
In Listing 6.11, we do not fail the workflow if serious vulnerabilities are discovered. However, you can find the scanning results in the security section of your Catalog Service GitHub repository. At the time of writing, no high or critical vulnerabilities are found in the Catalog Service project, but things might be different in the future. As already mentioned in Chapter 3, in a real-world scenario, I recommend that you configure and tune Gripe carefully and according to your company's policies regarding supply chain security, and make the workflow fail if the result is not compliant, setting the fail build property to true. For more information, refer to the official Gripe documentation. See this link. After completing the commit stage of the deployment pipeline, make sure your Catalog Service GitHub repository is public. Then push your changes to the main branch of your remote repository and see the workflow execution results in the Actions tab. Warning: the action of uploading the vulnerability report requires the GitHub repository to be public. It works for private repositories only if you have an enterprise subscription. If you prefer to keep your repository private, you'll need to skip the Upload Vulnerability Report step. Throughout the book, I'll assume all the repositories you create on GitHub for the Polar Bookshop project are public. Images published from GitHub Actions and named after a repository are automatically associated. After the workflow completes its execution, you'll find a Packages section in the sidebar of your GitHub Catalog Service repository's main page, with a Catalog Service item, Figure 6.16. Click on that item, and you'll be directed to the container image repository for Catalog Service.
Figure 6.16. When using the GitHub container registry, you can store container images next to the source code.
Note: images published to GitHub Container Registry will have the same visibility as the related GitHub code repository. If no repository is associated with the image, it's private by default. Throughout the book, I'll assume that all the images you build for Polar Bookshop are publicly accessible via the GitHub Container Registry. If that's not the case, you can go to the Packages main page, select Package Settings from the sidebar menu, scroll to the bottom of the Settings page, and make the package public by clicking the Change Visibility button. Great job! So far you've built a Spring Boot application that exposes a REST API and interacts with a relational database. You wrote unit and integration tests for the application. You handled the database schema with Flyway so it was production ready. And you ran everything within containers and dealt with image generation, Docker, cloud-native BuildPacks, and vulnerability scanning. The next chapter will complete the first part of this cloud-native journey toward production by diving deep into Kubernetes. But before moving on, take a break, congratulate yourself on what you have achieved so far, and perhaps celebrate with a beverage of your choice. Polar Labs. Feel free to apply what you've learned in this chapter to Config Service. 1. Configure the cloud-native BuildPacks integration and package the application as a container. 2. Update your Docker Compose file to run Config Service as a container. 3. Configure Catalog Service with the Config Service URL via the Spring_cloud_config_URI environment variable, relying on the Docker built-in DNS. 4. Bootstrap a deployment pipeline for Config Service by implementing the workflow for the commit stage using GitHub Actions. You can refer to the Chapter 06/06 end folder in the code repository accompanying the book to see the final result. See this link.